All right, well, this is where we were the last video. Okay, so this, yeah. So this in this we're talking about the melting of rock into magma occurs over a broad range. Okay, and I'll show you that in just a second. Partial melting is really the thing that happens. This is really within the mantle. So what happens is you have all this material in the mantle, and to some degree in the crust, where anything with a low melting point, which of course, remember we talked about this before with minerals. Things that have a low melting point have a high silica content, right? High, the SiO2 silica, which is what most rocks are made of, and so they melt first. So what happens is when you have a bunch of material and the stuff that is silica that melts first. So that silica we say that it's enriched, right? I mean there's just a certain amount of silica there, but because it melts first, there's more silica, and then those rocks that magma that forms from that partial melted stuff. If it cools, if the pressure lowers and it cools down, you're going to form silica rich rocks. All right, let's go to here. Let's take a quick look at this. All right, so I think I have it. Let me see. Oops, that's the wrong thing. All right, so right here, this I just Googled the melting point of rock, and so this is the range. Generally, it's anywhere from about 600. So this is Celsius, 600 to 1300 Celsius. All right, so in Fahrenheit, that's 1100 to 2200 degrees Fahrenheit. So that's what it takes to melt rock. And turn it into, of course, magma. All right, so let's go back to this. Let's see where I'm at. Mineral crystallizations systematically based on their respective melting points. So minerals with higher melting points will crystallize first. So we're talking about just kind of imagine you're way up here in temperature. As that temperature drops, right? So, maybe the pressure went down, and so the temperature is going down as well. Then, things with very high melting points, you'll drop below the melting point. Let's say if this is not a really good example of a scale, but you have way down here. Let's say this is the scale of things that are just pure silica, like quartz, for example, and then way up here, like things like conundrum, cordum, the rocks that are very low in silica, and so as you get below the temperature that those things will crystallize, those low silicate rocks will crystallize first, and then when it finally gets down to low enough temperature, you'll get stuff like quartz, for example. All right. Let's see. So minerals with low melting points, high silica, or they stay melted, as that implies. All right. So when we look and we see the types of magma around the world, there are basically three types. This basaltic, which will become basalt. We find this at the ocean basins. There's let me start with the next one is I'm skipping andesitic, but granitic. So this is where granite comes from. The vast majority of the continents you have granite underneath. The oceans have basalt underneath. And this andesitic, it comes from, it's just magma around the Andes Mountains. That's where the name comes from, right? It's andesitic, right? So those types of magma are they're it has to do with where you're talking about on the Earth. If you have ocean over you, if there's ocean and there's magma forming and there's a big ocean above, that's going to be basaltic rock. Although basalt will occur, of course, anywhere there's volcanoes. Um, you'll get granite near the continents, or right in the middle of the continents, and this type you find primarily in the Andes Mountains. It's just chemically different than the other two. Chemically different enough to have its own name. All right. So anyhow, all right, igneous rocks are classified according to where they come from. All right. When I mentioned this before, there's plutonic rocks, where the rock crystallization took place underneath the ground, and that's intrusive. All right. So I showed a little. I think it was the last video that I did. Anyhow, I showed a little picture where it shows the intrusive, and then so intrusive and plutonic mean the same thing. This has to do with like the Roman god of the underworld. That's where the name plutonic comes from. And then rocks that are extrusive, it means that the magma has reached the surface. So those are volcanic rocks. All right. So, and as I said, usually right around the volcano, you're going to find a lot of basalt. But we'll get to that a little bit later. And all right, so let's move on. All right, so these are different types of volcanoes. So this is a typical type of volcano. I mean, there's many. There's these three types of volcanoes, but on average, you find more of the shield volcanoes more often. So where does the name come from? The shield volcano. It's kind of a simplistic thing, and it goes back to the old days of of warfare, of human warfare, and like humans used to carry around a metal shield, and if you were to lay that shield, like the flat part down, that would be it kind of is the same shape as one of these shield volcanoes. All right, so the cinder cone volcano looks like this. It has a big crater, a big caldera inside of it, like that. The composite is kind of a combination of these. This is, for example, Mount Fuji. Mount Fuji is a good example of a composite. Notice it has, just like the shield volcano, its diameter is huge, right? Where the cinder cone, these things jut up very almost immediately from the ground, whereas like Mount Fuji has this incredibly large diameter, but right at the top there's this little indentation. All right. Okay, so igneous rocks that cool below the Earth's surface are called plutonic. We just went over that. Granite is the most common type of plutonic rock. And then you have these batholists. So a batholist is this large amount of plutonic rock. Sometimes that will will find its way above the soil. You'll just see granite rock sticking out from a mountain. A local example, right, would be like Table Rock, right? Table Rock has an incredible amount of granite that's sticking out above. It's right there in Pickens County. If you haven't been to Table Rock, it's kind of it's really cool. It's beautiful. You can see it from the highway, or you can climb. You can go up there and look around. It's really pretty cool. All right. So now we're moving on from igneous rock. Remember, igneous it was forged in fire. Basically, the igneous rock comes from magma, either magma that solidified under the ground or magma that's solidified uh, when it's exposed to the surface of the earth. All right, and this next one is sedimentary rock, and the as far as the rock, let's say identifying rocks. If you haven't had there's a lab where you have to identify the rocks. I think the sedimentary rocks are easier to spot. They basically, okay. And I'll go through all this, but the basic thing about these sedimentary rocks is they basically look like they're glued together. Like somebody, some kid did a little, little project and just glued a bunch of rock parts and things that you find on the ground. You glued them together, and that's these sedimentary rocks. All right, so that's it. Just in appearance, sometimes it's very easy to spot them. This is what happens. You have weathering, which I mentioned before. For example, water. It rains and you have some big boulder, and the rain is frozen. Let's say it freezes, and ice expands. And so when the ice expands, the little cracks, if there's little cracks in the boulder, it'll push against the boulder, and so that's one form of weathering. Erosion would just be water, right? Water hitting, pouring down on the rock, year after year, decade after decade, century after century, and so on, right? You get into millennia, some thousands and thousands and thousands, hundreds of thousands of even millions of years, and you will start to erode the rock. All right. The next one is deposition. So we were just talking about erosion, and what happens, when let's say the water erodes part of a rock. If let's say it's some flash flood or something, one imagines a flash flood or something like that, and the deposition, it would be like where that material, the rock material, ends up, right? That's the deposition. Okay, the sedimentation, of course, is the let's say dirt and leaves, or even fossil remains lay on top of this either weathered or eroded or deposited or deposition material, and so the sediment, the material builds on top of it. All right, so we'll get more into this in the next few slides. All right, so weathering is the physical breakdown and chemical alteration of rock at the Earth's surface. So there's two types. The one I've already mentioned, the mechanical weathering, the breaking and disintegration of rocks into smaller pieces. Like, for example, when it rains and it freezes, and that frozen water, water always expands when it freezes. So that's something that it can happen. What about chemical weathering? So chemical decomposition and transformation of rock. Is it just the presence of usually we're talking about water. The presence of it can start to break down the chemical, whatever's chemically making up that rock. And of course the rock in turn is made up of minerals. And so you're breaking those down, and you can turn the rock into one or more new compounds. All right, let's look at the next slide. All right, so let's say this is the mechanical thing I mentioned. So I don't have enough time to finish, but this is like the thermal expansion that I just mentioned, the heating and cooling. I mean, every day, especially in the South, you can have this huge variation in temperatures.